Welcome to Spelling Bee Ninja, where learning comes alive. Today, we're diving into the fascinating world of chemistry and exploring the periodic table, a unique chart that organizes all known chemical elements. From alkali metals to noble gases, this lesson will guide you through the essential concepts that make up the fabric of chemistry. We'll not only learn about the elements but also understand their properties and how they're organized in this incredible table. So, grab your notepads as we embark on this interactive chemistry journey. Let's start by talking about the periodic table itself. You might be surprised to learn that this organized chart of elements was first developed by the Russian chemist Dmitry Mendeleev in 1869. His innovative approach arranged elements by their atomic number, which is the number of protons in an atom's nucleus. Mendeleev's structure was not only groundbreaking, he also anticipated the discovery of new elements by leaving gaps in his table for those yet to be discovered. Fast forward to today, the modern periodic table boasts 118 confirmed elements, each with unique properties and behaviors. Now you might wonder, what exactly does the atomic number tell us about an element? Well, the atomic number is crucial because it defines the identity of an element. For example, carbon has an atomic number of 6, indicating it has 6 protons. It helps distinguish one element from another and is essential to understanding their chemical behavior. As we look at the periodic table, we can see that it includes vertical columns known as groups and horizontal rows referred to as periods. Groups, or families, share common properties. Elements in the same group have the same number of valence electrons, which are the electrons found in the outer shell of an atom. This similarity contributes to the chemical behavior of these elements. For instance, Group 1, known as alkali metals, includes elements like lithium and sodium, which are highly reactive, especially with water. On the flip side, Group 18 consists of noble gases like helium and neon that are virtually non-reactive due to their full outer electron shells. Moving horizontally across the periodic table, we have periods. Elements in the same period share the same number of electron shells, indicating the energy levels of their electrons. As we proceed from left to right in a period, we witness an increase in atomic number, meaning atoms become progressively larger. So, it's essential to understand not only how these elements stack up vertically but also how they arrange themselves horizontally. Now, let's categorize elements further into metals, nonmetals, and metalloids. The left and center sections of the periodic table consist of metals, which make up about 75% of all known elements. These metals typically exhibit characteristics such as being shiny, good conductors of heat and electricity, as well as being malleable and ductile. They form many different compounds and are integral to numerous applications in our daily lives. In contrast, nonmetals occupy the upper right corner of the table. They are generally poor conductors and display a range of physical states, including gases like oxygen and solid elements like sulfur. Between these two categories lie the metalloids, elements that possess characteristics of both metals and nonmetals and are crucial for making semiconductors that power our technological devices. Now, let's delve deeper into specific groups within the periodic table. The noble gases, located in Group 18, are known for their stability and lack of reactivity. Each of these elements possesses a complete valence shell of electrons, typically consisting of 8 electrons. This arrangement makes them very stable and unlikely to form bonds with other elements. However, there is an exception: helium, which has just 2 valence electrons. These gases are highly useful in various applications. For instance, helium is often used in balloons and neon lights, while argon serves as a protective gas in welding. Moving on, we come to the halogens, which occupy Group 17. These elements are highly reactive nonmetals that include fluorine, chlorine, bromine, and iodine. They have 7 valence electrons and are always looking to gain one more to fulfill their outer shell. This makes them eager to form bonds and react with metals, often resulting in the creation of salts, such as table salt made from sodium and chlorine. They also find uses in our everyday lives. For example, fluorine is commonly added to toothpaste to prevent cavities. Another fascinating group to consider is the transition metals found in groups 3 through 12. These metals are distinguished by their unique ability to form various oxidation states, leading to a vast array of colorful compounds. Examples include iron, copper, and gold, which are widely used in construction, electronics, and jewelry, among other industries. The colorful nature of transition metal compounds can be observed in everyday items, like blue copper sulfate and purple potassium permanganate. Let's highlight the alkali metals situated in Group 1. These are the most reactive metals and have only one valence electron, which they readily lose to form positive ions. The reactivity of alkali metals is so strong that they are stored under oil to prevent them from reacting with air or moisture. For instance, sodium reacts explosively with water, generating heat and hydrogen gas, while potassium demonstrates even greater reactivity. When handling these metals, precautions are crucial. Finally, we must brush up on the periodic table symbols. Each element is signified by a 1 or 2-letter symbol, where the first letter is always capitalized. For example, hydrogen is represented by H and helium by He. Interestingly, some symbols derive from their Latin names, such as sodium Na from natrium and iron Fa from ferrum. Understanding these symbols is essential as they are the shorthand of chemistry, making communication in the scientific community efficient. In summary, today we explored the periodic table, a structured compilation of elements organized by properties like atomic number and electron configuration. We learned how Dmitry Mendeleev pioneered this table over 150 years ago, and how it reveals vital information about elements, including their group behaviors and properties. Understanding the distinctions between metals, nonmetals, and metalloids provides insight into their functionalities in the world around us. We also took a closer look at specific groups like noble gases, alkali metals, and transition metals, uncovering their unique characteristics. Grasping these concepts is essential for your journey into chemistry, and I encourage you to continue exploring the wonders of the periodic table. Thank you for joining us on this insightful journey into the world of chemistry and the periodic table. We hope you found this lesson engaging and informative. Remember, the periodic table is not just a chart, it's a wealth of knowledge waiting to be discovered. Keep exploring, stay curious, and in our next episode, we'll delve deeper into the exciting concepts of chemistry. Until then, keep nurturing your love for science.